Hello there, Matt with LINBIT here, and today I'll be showing you how to get started with LINBIT SDS for Kubernetes using version 1.9 of the LINSTOR operator. If you've not deployed LINSTOR into Kubernetes before and you're curious what it looks like or how it's used there, then this video is right for you. If you're looking for deeper topics surrounding LINSTOR, I'd suggest checking out LINBIT's blogs, documentation, our knowledge base, where you can find those more advanced topics, and all that can be found by visiting linbit.com. To get started with LINSTOR in Kubernetes, you'll obviously need to have a Kubernetes cluster. I'm using EKS here, but any Kubernetes cluster will do as long as the hosts have an unused block device that LINSTOR can use for its storage pools. And if you'd like to use EKS like I am, you can create a launch template for your EC2 instances that attach that additional block device, and there will be links to resources covering that process in the description below. You'll also need your LINBIT customer credentials to access LINBIT's container registry. If you don't have these, you can reach out to LINBIT's sales team for them, or even to start a free evaluation. And you can do that via the contact form on linbit.com. Alternatively to having a customer account with us, you could use Piraeus. This is LINSTOR's upstream project, which is also developed by LINBIT. Deployment of Piraeus will be nearly identical to what you'll see here, besides the name and where you source the operator's Helm charts. But links to the Piraeus project's GitHub will be below in the description as well. The very last thing you'll need is Helm, since the LINSTOR operator is managed by Helm. It's very easy to install. I can link to that in the description below as well. And once you have all that done, you're ready to get started. So the first thing you want to do is create a namespace for LINSTOR in the Kubernetes cluster. It's optional, but it's nice to keep things tidy. And we need to create a secret which will store our LINBIT account credentials. And I have hid my credentials here behind some environment variables, but feel free to populate those as you need to. With the secret created, we can start adding the LINSTOR charts repository to our Helm installation. I already have this, so I'm just going to go ahead and update that to make sure I'm getting the latest version of LINSTOR. And now we can configure the operator's options in a file that we can pass to Helm during deployment. And this is a lot of typing, so I'll pause here and kind of explain what's going on. Creating this file that will pass during the installation, and we'll configure the operator to tell the controller to use the K8s or K8s DB connection. That just means that LINSTOR will store its internal state inside of Kubernetes CRDs. This is different than what we would have done in the past, which is stand up our own etcd cluster in Kubernetes or a Postgres database for LINSTOR to store its internal state. Then we'll tell the operator to configure the satellites and their storage pools, and we're going to use LVM thin pools. We'll name them LVM thin, the thin pool name thin pool. The volume group you'll need to leave blank. That'll be populated. In future versions, you'll be able to configure this, but not in 1.9. And then this is that device path, that additional block device unused attached to each of the hosts that LINSTOR will consume to create this LVM thin storage pool. And we're using the compile injection mode. You can use the prepackaged debs or RPMs depending on your distribution that you're running Kubernetes on, but we find compile to be the most robust option because it works for most Linux kernels, but you'll get a faster deployment if you do use those prepackaged RPMs or debs, so it's a trade-off there. We are not using etcd to store our state. We're not going to use stork here. And we're going to enable topology on the CSI layer so that we can use more intelligent placement of our volumes and pods. And we're going to enable the HA controller. I do that out of habit, but it is an optional component. It makes the failover of pods quicker in Kubernetes. and it's highly recommended if you do have quorum, and we can with the 3 nodes that we have. So we'll use all those options. We'll create that file, and many things can be configured during deployment. We configured the HA controller to help with pod failover. We said we wanted thin LVM, but you could configure thick LVM or even ZFS for the storage pools. And to see a full list of those options that you can set, you can check out the LINSTOR users guide on LINBIT.com or the Piraeus project's Helm reference table. It'll list out all those options. But finally, we can use Helm to install LINSTOR, and we are installing it into the LINSTOR namespace. We're using this options file to supply the operator with its options, and we're going to name this release LINSTOR op, and the LINSTOR is the chart name. So go ahead and install that. And we get some output, and we have some commands we can run and next steps we can take, but we'll just watch the operator start deploying. We don't have to watch the whole thing happen, but we see that it is going. And while that is going, we can go ahead and create our storage class definitions so they're ready when LINSTOR finally does complete its deployment. So there's, just like the operator options, there's a lot of options you can set on the storage classes themselves. Just to take this last one as an example, we're going to name it LINSTOR CSI LVM Thin R3. And I just throw this R3 on there because we're going to say place 3 replicas within the cluster. So for every volume we create, we're going to make sure that there are 3 replicas spread throughout the cluster. We're not specifying where they are, just that there are 3. That's the auto place setting. And we're going to use that LVM thin storage pool we created using the operator options and set some standard Kubernetes options for the volumes. But we can use the volume expansion option. So I've set that to true. And I've also set a LINSTOR specific parameter, allow volume access to false, and volume binding mode to wait for first consumer. And this will ensure that your pod or your volume gets placed on the same node that your workload, your pod, gets scheduled on. That just means you're going to be doing local IOs as opposed to using DRBD's diskless attachment, which is totally fine, but you're going to get better performance, lower latency access to your storage, and I just always do it. So we'll create that file, and then we can apply our storage classes to Kubernetes. We see we created those 3. There they are, in addition to our GP2 from EKS. And now we'll check to make sure that LINSTOR is finished deploying. And we see we have our cluster running. And now that we've installed LINSTOR and configured the storage classes, we can do all our normal Kubernetes stuff, like creating PVCs from those storage classes. And here we'll create a PVC. We'll name it demo vol claim 0, and we'll create it from that R3 storage class that we created in the last step. We're just going to ask for a small 4 gigabytes, and we'll apply that. And we can see we have that PVC pending because we told it to wait for the first consumer. So let's create a pod. And this pod we'll just name demo pod 0. We'll create it in the default namespace. It's just a BusyBox pod running this while loop, sleeps, and we're going to mount that PVC on /data. And here's the name of the PVC that we just created. And kubectl will apply that. And we'll check to see that that pod is running. And it is. And because we mounted that at /data, anything that gets written into /data will be synchronously replicated to each host with a replica of that volume. In this case, that's all the hosts. So if any individual node dies, there's a replica of the PVC in the cluster where we can run our pod from, without losing any data. And that's LINSTOR for Kubernetes in a nutshell. One last thing I'll show is just a view from within the LINSTOR controller, just to see that we have the volume listed in there. And there we see, where our volume is in use, where there are replicas. Yeah. And, that's the basics. And like I said, more advanced topics can be found from browsing around at LINBIT.com. And if you have any questions you'd like to ask LINBIT directly, don't hesitate to join the LINBIT Slack community or just reach out directly. We have that contact us form on the website, and that'll get you on the phone with me or some other solutions architect that you might have in your country. And that is all for now. Thanks for watching, and don't forget to like and subscribe.